Hello students, in this class we are going to deal with the topic arithmetic progression. Look at the list of numbers here. First one 1, 2, 3, 4 and so on. Here you can observe that the second number is obtained by adding 1 to the previous number, that is 1, and third number 3 is obtained by adding 1 to the previous number. Similarly, 4 is obtained by adding 1 to the previous number. And here in the second example, 100, 70, 40, 10 and so on. Here every number is obtained by subtracting 30 to the previous number. 100 minus 30 is 70. 70 minus 30 is 40. Again 40 minus 30 is 10 and so on. In the third example, minus 3, minus 2, minus 1, 0. Here 1 is added to the previous number. Minus 3 plus 1 is minus 2. Again minus 2 plus 1 is minus 1. Minus 1 minus 1 plus 1 is 0 and so on. In the fourth example, 3, 3, 3, 0 is added to the previous number. 3 plus 0, 3. Again 3 plus 0, 3 and so on. In the fourth example, minus 1, minus 1.5, minus 2, minus 2.5. Here minus 0.5 is added to previous number. That is minus 1 minus 0.5 is minus 1.5. Minus 1.5 minus 0.5 is minus 2. And minus 2 minus 0.5 is minus 2.5 and so on. So it is clear that in these list of numbers, every second, third and fourth numbers except first number, they are obtained by adding a fixed number to the previous number. Each number in this list of numbers, it is called a term. If you consider minus 1.5, it is called a term in this list. Minus 2.0, it is also a term. Minus 0.25, it is also a term. Minus 1.0, it is also a term. So every number in the list, it is called as term. So by observing this, we will define arithmetic progression. The definition of arithmetic progression is like this. An arithmetic progression is list of numbers in which each term is obtained by adding a fixed number to the preceding term except first term. So it means that every number in the list or every term in the list can be obtained by adding a fixed number to the previous number except the first term. It means to write any AP, you should know the first term and the fixed term. This fixed number in the AP, it is called as common difference. It is called common difference, and the symbol used for common difference is T. Remember that this common difference can be positive, it can be negative, or it can be 0. If you see the examples here, the common difference is positive, is 1, 1, 1. If you observe the second example, the common difference is negative, minus 30. And also in the fifth example, it is negative, minus 0.5. Whereas in the fourth example, the common difference is 0. So it can be asked in the multiple choice questions. Please remember it. The common difference can be positive, negative, or it can be 0. So we observed that an AP is nothing but a list of numbers. When we are writing the list of numbers, every number in the list is regarded as term. Okay, so in general, the first term is denoted by a1, second term is denoted by a2, third term is denoted by a3, fourth term is denoted by a4, and so on. Last term is denoted by an, or you can also say nth term is denoted by an. Okay, here a2 can be obtained by a1 plus d, a3 can be obtained by a1 plus 2d, a4 can be obtained by a1 plus 3d, and so on. An is a1 plus n minus 1 into d. In general, the general form of AP is written as a, that is first term, comma a plus d, a plus 2d, a plus 3d, and so on. Okay, here a stands for first term of AP. First term of AP is generally indicated by a. So general form of AP is also very important. Remember it: a plus d, a plus 2d, a plus 3d, and so on. Whenever we are talking about the AP arithmetic progression, there are two possibilities. One is the AP can be finite or it can be infinite. Finite AP means there are fixed number of terms in the AP. It means we know the last term in the AP. For example, consider an AP 2, 4, 6, 8, 10. So here the first term is 2, common difference is 2, and the last term is 5. There is no further numbers after 10 in this AP. Therefore we can say that this is the finite AP. In case of infinite AP, we do not know what is the last term. For example, 2, 4, 6, 8, 10, dot 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 dot. It means that the AP is continuing. There is no end to this AP. Therefore, it is called as infinite AP. Okay, finite means there is a last term in the AP, and infinite AP means there is no last term to the AP. Look at this list of number. Let us find out what is the difference between two consecutive numbers. 3 minus 2, it is 1. 5 minus 3 is 2. 7 minus 5 is 2. 8 minus 7 is 1. 10 minus 8 is 2. 11 minus 10 is 1. Here you can clearly see that the difference between two consecutive numbers is not same here. Therefore, this is not an AP. Again, if you see the second example, second list of numbers, 6 minus 3, 3, 12 minus 6, 6, 24 minus 12, 12, 48 minus 24, it is 24. Here also the common difference, or you can say the difference between two numbers, consecutive numbers, is not same. Therefore, this is also not AP. In the third list, 1 minus 1, 0, 2 minus 1, 1, 4 minus 2, 2, 7 minus 4, it is 3, and 11 minus 7 is 4. Here also the difference is not constant, it is not same. Therefore, this is also not an AP. From the general formula, we know that AP can be written as a plus d, a plus 2d, a plus 3d, and so on. It means that if you know the value of first term and if you know the value of d, you should be able to write the AP. For example, if I say that write an arithmetic progression in which a is equal to 3 and d is equal to 2, then how will you write? A value 3, a plus d, 3 plus 2 5. Next a plus 2d, 3 plus 2 into 2 4. So 3 plus 4 is 7. Next 3 plus 3 2s are 6 9. Again 9 plus 2 11 and so on. So from this, if you know value of a, if you know value of d, you are able to write the arithmetic progression. And also if you know the arithmetic progression, then you should be able to write the, to identify what is the common difference and what is the first term. Here in the second example, if you consider 100 70 40 10, then you can easily say that first term is 100 and common difference d is 70 minus 100, that is minus 30.